When I first started teaching Splunk, I thought you'd learn how to install it and set it up and configure it, and I realized that is not an entry-level job. The entry-level people will just use it. It's a more advanced job to set it up, so that's where I should start. That's why I switched to this, where you learn how to use it. And so last time, we found the first few facts about this, the address of the server, one of the attacker's addresses, and the file they used to deface the server, and the server. So the attacker controls two servers, one starting with 40 and one starting with 23 that we know of so far. And what we know now is somehow they tricked the web server into making an outgoing connection and downloading a file. We haven't figured out how they got that privilege on the web server, and we haven't found a ransomware attack, which we'll find. But one thing you can do is you might want to understand this fully qualified domain name. We found this by just looking around, prankglassenebracket.jumpingcrab.com. That's clearly a domain name controlled by the attacker. So that's some information about the attack. So now we found a staging server used to host a defacement file, and we got that IP address. This may or may, if you look, once you find a malicious server's IP address, then typically they compromise or purchase a bulletproof server, and then they use it over and over again for criminal campaigns. So there are online threat intelligence services like Alien Vault that will let you search. And here we're searching for that address, 22, 23, 22, and so on, and it will show you the history of this address. So it was there. It was used for various things. It was WayneCorpIncorporated.com, and then just an Amazon address, and then PoisonIvy.com in the past. And this is what flag is: find the LeetSpeak domain. And this, of course, is the trick that hackers use to use numbers instead of letters, an old trick to sort of obscure things. So that's this is very useful. DNS history is extremely useful. If you read Brian Krebs, a journalist, he tracks down the names and address of real threat actors, because the typical evolution of a threat actor is they start out playing games and they make a website, and then they start cheating at games, and then they start hacking games, and then they start doing real crime, and there's a linear path. So you can just track them back through the username, an old email address, or very often a domain name. They keep the same server and just buy more domain names, and you can just follow them back. So this is how they get the information on whole campaigns from threat actors, which you see a lot of. All right, and so we want to find the, so here, let's look for the brute force attack. This is pretty interesting. So we're going to find how they got on the web server. So we're going to get the web traffic. So I'm just going to start here with data summary and source types. And again, I'm going to start with the HTTP traffic, which is here. Okay. And now, as usual, to make it faster, I'm going to do 1 in 100 sampling. And now go to all time, just to make it faster. So here's a lot of HTTP packets. Now, what I'd like to do, I want to find the events using the post method, because I'm looking for login events, and those are typically posts. So if I go down here, I should be able to find the HTTP method. If you click it on the left, what it will show you is the options that are available and how many of each type there are. So here's the posts. So if I just click that, it's going to add that to my query. So now I got HTTP and method equals post. Okay. Now, I know there should be 15,570 of them. So let's get rid of the filter and make sure I'm getting the right number. And when I worked in databases, this is one rule. You always record how many you're going to find and check it. Like before you ever update anything, you do a select and make sure you're only affecting the right number of rows, because it's very easy to accidentally update all the rows when you don't mean to. That can be a disaster. So paying attention to the number of results is a very common control to make sure you're not falling off the track. So this is right. That's how many post methods there are. Now I want to get rid of the ones from the vulnerability scanner, which we found last time. And the smartest way to do that, I find, is again to break the rules and just use it like Google. So I just want to, I put here not, which must be capitalized, and then Acunetics. And this just means that word cannot appear anywhere in the log. So that should remove a lot of it, and it does, almost all of it. Now I'm down to 441 events that didn't come from the scanner. Now I want to look at the form data of these events, and one thing that's really handy is to do this. You can make a table, and the time field, underscore time, is automatically created by Splunk. It's included in time editor record. So if you leave it this way, it shows you every event one by one here, every log entry, and a simple summaries here of just one field. But if you want to zero in on one thing, you can make a table of just time and form data. And then you get this layout, which is extremely useful. So here's ones with empty form data. Here's ones with form data. This is just random Joomla stuff. But if you go to, say, a couple pages in, now you're starting to see the brute force attack. Here's admin and password equals Godzilla, password equals lifehack, password admin, and I expected to see password over there. Anyway, so you'll notice there's some other ones at the start that were random traffic with random stuff in the form, but then there's ones that are clearly brute force attack. Many, many guesses, all with admin, and if you look at the time, there are many guesses per second. 45.5, 45.3, 45.3.3. This is a brute force attack with many guesses per second, all trying to get into the admin portal with different passwords. That's a brute force attack. So to get rid of the ones that are not part of the attack, I'm going to search for a characteristic string like this. They should have that in the field. So I'm going to add that to the query. If you don't say not, then it will require that that's in the field. It's just like Google. So it has to contain this, it has to not contain that, and then there are these parameters. So that should get rid of the stuff that is not part of the attack. That gets me down to 413 events, and now you've got the whole timeline. And if you click this, it'll sort by time. So if I click it once, now I'm going to see this is the start of the attack, I think, 26, 24, yeah. So here's this, it's admin, password is 1, 2, 3, 4, 5, 6, 7, 8, then admin, and password, I don't know why I'm not seeing the password on that one. Let me try making the font a little smaller. Yeah, the password's over here, let me in, just isn't quite fitting on the screen. Here's the password, QWERTY, here's the password. So this is a brute force attack. And you can see it's an automated attack, really fast, many guesses per second. And that goes on and on. But if you go to the other end, when that's done, then you'll find, here's the brute force attack going 50.6, 50.6, 50.6, trying different passwords. Then at the very end, 51.3, and then 46, then 48. 2 minutes go by. And what happens here is the brute force attack is an automated script running, trying many passwords until it finds the right one. Then it pops up a box, then 2 minutes go by, then the hacker logs in interactively using the password. That's why there's a gap. You can see it that way. You can also see it this way. If I don't look at the table there and do it just looking at all the events, then I can also spot them by the HTTP method, which is here. There, HTTP user agent. The Python script is 412 of them, and this is a real browser coming in later. So you can see the timeline of the attack. And by the way, I think they logged in from a different IP address. Let's take a look at that. Source IP. There's a client IP. Client IP. Yep, here's the brute force attack was run from this computer, and the interactive login came from that computer. So you can see just what they did. And so, anyway, that's there's quite a few flags about that. You know, find the events, find the IP address doing it, and find the first brute force password used, find out when it found the correct password, find the time interval between when the brute force attack found the password and the guy logged in. So now you know how they got in. They brute forced the admin panel of the web content Joomla, and then they used that to make an outgoing request. So again, there's a missing step there. They must have uploaded some kind of file and run it. And that's what we're going to find now. We're going to find the uploaded executable file name. So we start, as before, with the HTTP events using the post method, and then exclude the vulnerability scanner. All right, so that was this up to here. That should give us the 441 events or something like that. Yep, so these are the login attempts or other posts. And then we're going to look for extensions of Windows executable extensions like .exe. And that gives us 2 events. And we can just look at them and see what's going on here. And here it is, some kind of directory showing all the files. And here it's posting Joomla. And in the summary here, you are going to see, let me make this easier to see on the screen. There we are. Here's going into this administrator page. And somewhere in here, you're going to see the name of this file. In fact, the easiest way to do it is to use Control F. Control F.exe. That will highlight it. And let me go here. Oh, got to spell it right. EXE. There we go. And there's 6 of them. So there's one. And there it is. That's the file name, 3791.exe. And this is very common if you use hacking databases like you'll find in Metasploit. You have a list of all the known attacks for the known vulnerabilities, and they just have numbers. So you search for an attack against Joomla, and you find the file. So you upload this in the admin panel and then run it, and that's what did the outgoing request. So we pretty much reconstructed how they did the defacement of the web server. And another thing worth knowing, we should find that file's MD5 hash. This will show you the benefit of Sysmon. So Sysmon event IDs, this is why you use Sysmon, because the Windows Logger has thousands of different kinds of events, and they're all very hard to understand, a tiny little esoteric detail changing. Sysmon is exactly the opposite. There's only about 10 different kinds of events, and they're very simple. They come down here. You are event. Come on. Okay, here's the event. Event 1 creates a process. A process changed the file creation time. Network connection, service state change, process terminated, driver loaded, image loaded, create thread, raw access, process access, file create, and registry event, and that's it. The things you care about, and not a bunch of garbage. And each one of them comes with lots of useful information. So here, we're trying to find out when they executed that file, so that's going to be number 1, process creation. So you want to see event ID 1 from Sysmon. So what you do, let's go back to the original raw search page, back to Splunk Enterprise to go home, and then search, just get a clean start. And now, let me make this window fit on the screen a little better. All right, now you go to Data Summary, and Source Types shows, here's Sysmon. So I can just click that and see the Sysmon results. And now I'm going to turn on, as usual, event sampling just to make it fast, and go to all time. And now I should have some events, and not a ridiculous number of them. Now I can go down here and find the Sysmon event ID. And see, it only goes from like 1 to 10. And the ones I care about are number 1, the process creation. All right, I'll go back to my hints, find the process creation, and now look at command line. So now, there's only 8 of them, so let's turn off the filter and see them all. And now I want to look at command line, which is down here, and it shows you some of them. Now by default, it only shows you the top 10. And I want to see them all, so I'm going to make a table of command line like we did before. I'm going to go pipe table, and I think I'll do just command line. See how that looks? There, now I did just the command lines. And one thing I wonder is if I'm going to have duplicates, 132. I think there's a dedupe command. I think it's just dedupe command line. Let me just look it up to make sure. Example. Actually, AI might do it. How do I dedupe a field in a Splunk query?
There is, yes, there's a dedupe.
There is, but I don't remember the exact format. And I think the AI will tell me. Yep, deduplicate based on a single field. You just pipe dedupe. Okay, that's what I thought. I just don't remember whether it goes before or after the table command. Let's try here. I think probably before. Pipe dedupe, command line. There, see what that does. Okay, it could be, what, 34? Okay, here they are. Here's the various command lines. And what I'm looking for here is I want to find the file's MD5 hash, or the executable file they uploaded. So I think I want to find that 3791. And I would expect to see it somewhere here. Another way to do it, since I remember the name was 3791, I can just add that here. And if I remember that number right, I think it was 3791.exe last time. And if it is, that should really do it. That should narrow it down to 4 events. Okay, there they are. So these are the command lines that contained it. And so you can look at these to find the file hash. If I don't look at the table, but just look at the actual raw events, you'll see all the information about those events. Let me get rid of this. There, just 3791 will do it, only the relevant events. And now you can see here quite a lot of data. Let me expand it and format it out. There we go. All right, and so you've got the command line here. This is cmd.exe, and here's hashes. But I think that hash is of cmd.exe, not the malware. Although the parent image was 3791. So I think I'm not going to see the SHA of the actual executable program. I think it's the next one or the one after. So this one, trying to expand it, and it's giving me grief. I want the second one to be expanded. There we go. All right. And now, here's the hashes, SHA-1 and I think SHA-256. And that's the cmd.exe image again. Let's go down to the next one. Okay, 1, 2, and this is the third one. My GUI is giving me some grief. All right, there we go. And so now this time, where is the command? There it is, conhost, and again some hashes. And let's look at the last one. There. All right. There, this is tmd.exe, and there's that 3791.exe, piping it somewhere. So then you see some hashes here, and like I said, it can be confusing. When you see a hash, you don't really know if that hash is for the cmd command or for the 3791 command, and there's only 3 different hashes available, so I just tried them all. But if you read the syntax, you could figure out which one of these is exactly the hash you want. In practice, if you look here, there's MD5 hashes. And if I can get it to stop scrolling all over the place, there. You see there's only 3 of them. 3 of this one and 1 of each of those. So one of these is the answer. And anyway, that's why I thought it was extremely useful. That's why Sysmon is so good. This is information you need, and this is not in the Windows event log. That's one thing you really want to do is add Sysmon to all your servers. All right, and so there's a whole bunch of flags that come from that. And the next thing is the ransomware attack, but I'll do that in a separate video. So there's several things for you to find there.